Come here and look. This is the Clark refractor. It's a telescope. It's 10 meters long. It's got a lens this big, okay? And you can look through it every night. For 100 years, people have been looking through it. And they haven't seen not one alien spacecraft, okay? Zero, goose egg, nada, okay? Every night people look through it. They take pictures and pictures and pictures. And do they see one alien spacecraft? No! So that doesn't mean they're not aliens. There's got to be aliens, okay, because there are 50 billion galaxies. Each galaxy has what? That old saying, billions and billions of stars. But to say that aliens come here and cut open cows, take people up into their spaceship, hypnotize them, and nobody notices with this thing, I mean, it's just not extraordinary proof, okay? Extraordinary claim, aliens come here, extraordinary proof. Boy, we don't have it. This is the real science. This is what's really cool. Did you know that the Earth goes around the sun and the moon goes around the Earth in a very predictable cycle? Very predictable. See, the moon is always the same. It never changes. It's the same size and shape, round like a ball. But it looks different to us here on Earth because of the way sunlight hits it. That's right, moonlight is really sunlight. And it changes because the moon is going around the Earth, and the Earth is going around the sun. Everything's just going around. Okay, let's say that this baseball diamond is the orbit of the moon. Now, the diamond's square and the orbit's round, but you get the idea. Now we need a sun. So let's say that the Earth is on the pitcher's mound. Now see, by the way, the scale of this globe and this moon are about right with respect to the orbit of the moon. That's the baseball diamond. Now notice that right now, when you're standing on the Earth, you can't see the moon at all. This is what we call a new moon. And the reason you can't see it is the moon is between you and the sun. Now the moon orbits the Earth in this direction. So when the moon gets to first base, it's a half moon because sunlight is falling on half of it. Huh? Then it keeps running to second. Now when the moon's back here at second, it's a full moon. That's because the moon is on this side of the Earth. And here's a trick. The moon's orbit isn't flat. It's tilted. So a lot of times, when the moon's back here, will be way up here. But notice it's still a full moon. And this is why most of the time the Earth's shadow doesn't fall on the moon. It's almost always full. Got to keep moving. On to third. So over here at third, it's a half moon again. But look, the shadow's on the other side. That's because we're on the other side of the Earth. Well, time to break for home. So with the orbit set up like this, the moon would end up right on home plate. The moon scores a home run every month. Well, that's astronomy for you. Electricity is the flow of electrons. Electrons are the tiny particles that buzz around the outside of atoms. Now, when electrons are able to jump from one atom to another, well, that's the flow of electricity. Now, in some materials, like metals, electrons can jump from atom to atom very easily. This plug fits in this socket perfectly, but this plug is from Europe, and it doesn't fit in our sockets. No way. See, different countries use different style plugs for their electricity, but notice that they all have two prongs. That's because electricity has to flow in a loop. So it goes in one prong through this wire, through an appliance like this blender, then out the other side and back into the wall. It's a circuit. Between where I'm standing and wherever you're sitting, there are millions of different types of plants and animals, millions of different species, all living together in an environment in something we call an ecosystem. Now, in order for an ecosystem to be successful, in order for it to be healthy, it has to have different kinds of plants and animals. Lots of different kinds of plants and animals. Something we call biodiversity. Now, biodiversity sounds kind of complicated, but if you listen, it also sounds kind of nice. This is the Earth, our world. All the living things that we know of live here, and they live in ecosystems. Places like tundras, taigas, savannas, grasslands, prairies, deserts, steppes, intertidal zones, subtidal zones, continental shelves, deep ocean zones, estuaries, deciduous forests, temperate rainforests, tropical rainforests, Arctic ice packs, wetlands, marine mudflats, and cities. That's a lot of environments, but there are a lot of living things to fill them up. The Earth's environments are just crowded with life. Living things take hold everywhere they can. We can think of an ecosystem as this wooden puzzle game. See all the different species? They all fit together, and they depend on each other to live. Now, you know, once in a while, a species will go extinct. It'll disappear from the ecosystem. And you can see how you could lose a few of those without too much trouble. But if you start to lose too many, the whole thing becomes a little rickety. Now, where do people fit in? Well, look, they fit in just about everywhere. Look, just about anywhere you can walk, you'll find people living, because people are living things, and they're part of the ecosystem. So, when we go to manage an ecosystem, we have to be careful about how things fit together, or there won't be a place for us. We have to be very careful. Extremely careful. The moon doesn't just sit up in the sky either. Its gravity pulls on everything on Earth, including the ocean. So see this? This is the high tide mark. And way over there is the low tide mark. Now, along with the sun's gravity, the moon's gravity makes the ocean move from there to here every day because of the pull of the moon's gravity. Now, what's the main reason we have tides? Because there's a moon. Energy can make things change phase. Like, this burner is providing energy that makes this liquid water change to water vapor. It's changing phase from a liquid to a gas. Now, watch this. This is liquid nitrogen, and it's going to change phase too. I'm going to pour it into this flask, and it's changing from a liquid to a gas without the help of a burner. It doesn't need it. That's because it's so cold, minus 196 degrees Celsius, that the energy in the room is able to make it boil. This stuff looks kind of dangerous, doesn't it? But it's nitrogen. It's the same gas that's between you and the television. 78% of our air is nitrogen. So, the heat from the room makes the molecules move faster and faster, and they get farther and farther apart. And they change from a liquid to a gas. Now, what happens when molecules slow down? Well, they get closer and closer together, and some unusual things can happen. Here, let's try something. We'll take this, it's a rubber ball, this, ordinary onion, and a few of these, marshmallows. And we'll put them in liquid nitrogen and let them cook for a while. Come back in a couple minutes and we'll see what we get. If you just joined us, we've been cooking with liquid nitrogen. Liquid nitrogen is minus 196 degrees Celsius. It makes molecules slow down and get closer together. Here, watch. It's an ordinary rubber ball. Here's an onion. Oops. Liquid nitrogen gives you an unusual way to slice it. Astrology started out as the study of the motions of stars and planets. Most astrologers take it a step farther than that. They claim they can tell a lot about a person's personality just by knowing when you were born. Now, that's a claim that's pretty hard to prove. Now, 2,000 years ago, astrologers believed that the Earth was at the center of everything, and the stars and planets were attached to a big dome or sphere. They use names for groups of stars, and we still call them constellations. This one is supposed to be fish. Now, if we could go way out in space and look at the same group of stars, like this, well, we wouldn't see a fish anymore. Anyway, it is interesting to note that the gravitational pull of all the stars in this constellation is way less than a trillionth of the gravitational pull between you and the television set you're watching right now. Does that mean astrology is wrong? Well, astrologers make claims that can't be proven or disproven. They're vague, they're wishy-washy. Now, that's not science. It's, well, you decide. How do we know that atoms combine to make molecules? This is H2O. Water. 2 parts hydrogen and 1 part oxygen. When the atoms come together, they stick. Okay, but how do we know? Well, take a look at this. In here, we have some water. And we're passing electricity through it. When we do, we get 2 gases. If we let it go long enough, there'll be no liquid left at all, just the gases. And they're pure. They're each made of just 1 kind of element. On top of that, there's twice as much of this gas as this gas. By doing a lot of experiments like this, scientists have figured out that, well, H2O is 2 parts hydrogen and 1 part oxygen, with the hydrogens on one side and the oxygen on the other. Kind of like mouse ears. See? H2O is great. The ocean is made of H2O. You and I are full of H2O. It's wild. It's wonderful. It's water. Almost everywhere you go in space, there's nothing. It's empty. There's zero, nada, zilch, zip. That's because space is a vacuum. It's a void. It's almost devoid of everything. That's why astronauts have to wear spacesuits. Take a look at this. It's our vacuum of space, vacuum chamber of emptiness, of space, of science. And this is cherry soda. Soda has gas in it. You've seen the bubbles. Well, your blood has gas in it too, like oxygen and nitrogen we get from the air we breathe. Now watch what happens when we put the cherry soda in a vacuum. As we take the air out of the chamber, there's no air above the liquid to hold in the bubbles. So the gas comes out of the soda. You see, the same thing would happen to you in space if you were in the vacuum without a spacesuit on. That's why astronaut spacesuits and spaceships have to be airtight, or human bodies wouldn't work. Look at that. This would be like your blood in space, and it would be boiling in the vacuum of space. A is for atom. That's right. A is for atom, because atoms are the basic building blocks of all matter. Atoms are like the letters in the alphabet of the universe. So look what happens when we combine these letters. We get words. Atoms are like letters, and molecules are like words in our universal alphabet. All matter is made of atoms and molecules.
Hey, science guy.
Huh?
Even a banana cream pie?
Oh, yeah. Even a banana cream pie.